Hello everyone, I'm Andrea, and today I interview the PoliTo Rocketry team from the Politecnico of Torino. Okay, so could you tell me who you are and something about your team?
Yes, so my name is Fabio, and I'm the team president, and I'm the chief engineer of Project Cavour, which is our flagship project, which is a solid-propelled sounding rocket. And well, with me there is Andrea.
Hi everyone, I am Andrea. I am the logistics manager of PoliTo Rocket Team, and I also work in the mission analysis division, where we perform the flight simulations and the analysis of the flight of the rocket.
Yeah, so our team was born almost 1 year ago, a bit more than 1 year ago, and it was born with Project Cavour, so with our first rocket. And as of now, the team, we are from Turin, from the north of Italy, and we count almost 100 students from the bachelor's and master's programs, and also some PhD students. And our work is divided between the Cavour rocket, which has competed very well in the Spaceport America Cup 2023, just a month ago, and that will compete again at the European Rocketry Challenge 2023, so in October. Also, we have another project that is called Project Festo, which is a bioliquid rocket engine, which is another very important project that we hope to finish at the end of 2024/2025. It's really a question of funding and all the things that we have to go through before having a real engine.
So in 1 year, you've made the rocketry team, went to America, and are going to go to EuRoC, and are working on a liquid engine.
Yeah, that's a lot. Personally, I started working on researching on a sounding rocket, in October, November 2021, and at the beginning it was just a project between me and some friends. But then we got the help of a professor, and we founded a team at Politecnico. So yeah, 1 year ago we founded the team in June 2022, and the work started on Project Cavour. Yes, and we worked pretty well and pretty quickly, because we built the rocket, we tested it, we flight tested it in Germany in April 2023, and then in June we launched it from Spaceport America in New Mexico, and it was amazing. Yeah, and we did everything in a pretty short time, so it was really complicated, but at the end, it was really worth all the work. And with Project Festo, it will need some more time, of course, because it's pretty complicated, but we hope to get it done, also that really quickly.
How is your university?
I think our university is a really great university. I really like studying at Politecnico di Torino, both because the quality of the courses I think is very high. At the end of your studies at Politecnico, you are really ready to work in aerospace industries and also in the other sectors, because of course Politecnico covers every area of engineering and also architecture. The quality of the students after studying at Politecnico is very high, and a lot of industries that we are in touch with said that. I think studying at Politecnico di Torino is never a bad decision, and also I believe the quality of life in Turin is very good, very high standards, because it's quite a big city, but it's not like the biggest European cities like London or Berlin, for example. So you have a lot of things to do if you want, of course. You can go out, there are plenty of things to do, but it's not too crowded, it's not too messy. So it's perfect for university students, and in particular for engineering students, because as everyone knows, we study a lot, so we also need a city that is not too crowded. And also the environment and Politecnico, I think, is very nice. It's a pleasure to go on lectures and to spend time there. It's very enjoyable. I'm very happy to have made this choice of studying at Politecnico. And cost of life is a bit higher than other Italian cities, but it's not too high. It's not as high as I think other big university cities around Europe.
What job opportunities do you have after you finish university?
Well, I can say we have plenty. Turin is the capital of the aerospace industry in Italy. There are plenty of industries, both in the aeronautical and the space sector. And of course, Politecnico di Torino is one of the first choices for these industries. In terms of networking, I might add that we are doing a lot of work in networking, both with industries, with the aerospace industry, let's say, Society of Turin, which is a big district of industries that collaborate together, and with the universities. And also we're doing a lot of networking with students and with Rocketry students team in Italy and also abroad.
What are your team's goals?
Well, of course, the main goal of PoliTo Rocket Team is to contribute to the innovation in the space sector in Italy and in Europe, starting with our first rocket, Cavour, which is a solid propelled single-stage sounding rocket, and with Project Festa, which will be the first Italian student-made liquid rocket engine. It is a big goal, you know, and of course, with the main goal of producing research and innovating in the rocket engineering field, we're also providing students of Politecnico with real practical engineering knowledge, because courses at Politecnico are quite theoretical, but the work that we do is really practical. So students really learn a lot, and they learn a lot, and they learn to work in a team and as a team. As a roadmap, well, in 1 year we had the goal of testing and launching Cavour, our rocket, and we managed to do that. So in October, we want to launch again the rocket, same rocket in Portugal at EuRoC. And well, for the next year, we pretty much have the same goals. Of course, we want to build a much more evolved rocket for next year. So we do not know yet if we'll be able to make it to Spaceport America. But of course, Spaceport America remains the main objective. I can say that also for this year, Spaceport America was the primary objective. And then, of course, we got admitted to EuRoC, so we could not, you know, lose the opportunity. But our primary objective remains launching at Spaceport America for sure.
We want, as you said, we want to provide our members more technical experience. But I believe a very important part of this experience is to provide our members with a more enjoyable period at Politecnico. It's not just a matter of experience and technical quality as engineers, but we also want them to have fun and to become friends, to have an enjoyable 5 years, we hope, or less. It depends on when they enter the team, but we want them to have fun, and I think this is also one of our primary objectives. We really focus on that with the work of our division.
And then, of course, in the long term, our goal, well, for next year, we want to build still a solid propelled single-stage sounding rocket capable of having a scientific payload in a CubeSat form factor. And in the next years, well, we want, of course, to integrate our Festo biliquid engine with a rocket to produce a biliquid a rocket with a biliquid rocket engine capable of flying over 9 kilometers. So 9 kilometers at EuRoC and 30K feet at Spaceport in the liquid S3 category. Of course, this is a really challenging goal because, well, just building and testing the biliquid rocket engine will be really a difficult task. Then integrating it with the rocket will be much more difficult, but we are really optimistic on our future. And I hope that, well, in the next 2 years, we might have the first Italian student-made rocket with a biliquid engine.
How do you recruit new members to your team?
We have 2 technical projects, Cavour, the rocket, and the Festo, the engine. And then we have another sub-team, which is the operations sub-team, which is divided in logistics, media, and IT. And the recruitment is managed by logistics. So, yeah, Andrea can take that.
Yes, of course. The recruitment process starts when, of course, a division lead decides he needs new members. And so he's the person who starts this process, and he specifies the roles of the people he wants to recruit. And then the process goes on with the operations sub-team. And the IT division prepares a link on the website with we have a form to fill in for people who want to join, and so all the answers of this form are then read and studied by the division lead. And then there is the interviewing process. So all the candidates that are considered most suited for the roles are interviewed, and when the interview is done, if it went well, then new members are asked to sign a non-disclosure agreement, and they officially become part. They are inserted in our communication channels, and they start working. At the moment, the recruitment is open. I think the recruitment is quite always open because there are always some positions that are needed, some new positions. Most of our actual members joined the team in November at the first big recruitment. I joined in November, and at the moment there are some open positions, and everyone can visit our website and see what are the open positions and all the details, and apply if they want. Of course, the biggest recruitment of the year will be in September, when new students join Politecnico.
Of course, during the summer, some students leave. So in September, October, there is usually a large recruitment. But every position qualification is decided mostly by the division lead or by the chief engineer. We also accept remote students, with some exception. It depends. For instance, some positions in the IT divisions can be done also in remote. There is no need to be at Politecnico. We technically have the need for members to be students of Politecnico, but we can make exceptions for particular cases. And definitely our ideal candidate is someone who, first of all, has a passion for rocket engineering, and then who is willing to do anything, both technical and non-technical tasks. Many students come to us just expecting to receive a training and just work on rocket engine, but recruitment is really tough. Last year we had an acceptance rate of around 15%, maybe lower, and we had hundreds of applications, I think over 400 or 500. So it's really tough. So we're looking for people who are willing to do anything, and we're passionate about it. And of course, if the students start with some skills, of course that's better. But we admitted many students who had zero skills, and we did not admit many students who had some skills, but they weren't willing to do a task or a particular role. We do not have some particular technical questions for everyone. It depends. Maybe at the interview we had a technical part at the interview, if a member is selected for the interview, because that's also quite tough, because we have too many applicants to interview. So we may have some technical questions at the interview, but we mostly are looking for people with a open personality who are willing to work good in a team. And to promote the recruitment, we are organizing events. Of course, before the recruitment in September, October, there will be some events at Politecnico, and also during the entire year we were promoting STEM, and we have done many events of outreach, also with Andrea. So we are always trying to promote rocket engineering and STEM, both at the university and outside.
What skills can members learn from your team?
Really many skills, both technical and non-technical. So I think the first one is, to work in an environment which will be similar to the one then students will be in when they start working. So they work as a team in a division, which is in a sub-team, and that division is assigned some particular tasks. So they have things to do, to complete, for achieving the goal of the entire sub-team. So first of all, they learn to organize themselves and to organize their work. They learn also practical skills. Well, of course, students in the recovery division of the recovery sub-team will learn about all the recovery systems, so parachutes and other release and recovery systems. Students in the avionics division will learn to, we use C, so C++, so they will work with that. And they will learn to work with avionics systems and electronics and PCBs and all that. Students in mission analysis, I think Andrea can answer that. All the skills they learn in simulations.
Yes, I had zero experience in simulations, and I had to learn by myself everything I needed. But I'm really happy about my work, and we perform simulations on the Openrocket, so that is very easy. But we also got some experience with Python, because we simulate flights also using the RocketPy library. And the mission analysis work is it's very interesting and also creative, because it involves, for example, the analysis of some physical systems, and every task is different. Every time you have to adapt to the new task and learn new things by reading reports, and apply everything that you learned during the Politecnico courses to solve very specific problems.
How do you design your rocket?
That's a difficult question. So it's really an iterative process. First, we start with a goal, so the main requirements of the rocket, which in our case, well, were to have a rocket which was as cost effective as possible, because you know budget is limited. So the key points were to be reusable and reconfigurable. That means that our rocket is capable to reach apogees of 1 kilometer or 5 kilometers or more. Of course, in this range, we have the 3 kilometer target, which is the one of the competitions, which is the most important one. So we have a modular design with components that we can interchange to have different mission objectives, such as system testing. We want to test the avionics, we want to test the recovery system, we want to test the payload, we want to have some specific acceleration at the beginning, or we want to have a lower one, we want to have a maximum velocity, which is supersonic or subsonic. We can do that. We can modify our rocket without exchanging too many components, so we save a lot of money, and we can do that really easily thanks to our design. Another point is of course, reusability. We launched the rocket in Germany in April, and we reused the same rocket at Spaceport. We plan to reuse basically the same rocket also at EuRoC with some components change, thanks to the recovery system, of course, which is a pivotal point of all rockets. So we need to have perfect recovery all times to retrieve the rocket. Another point is, weight saving. So sometimes, most of the times, weight saving and cost saving, they don't get along really well. In our case, basically weight saving meant cost saving, because our rocket is extremely light. Basically, we have a rocket which is, without propellant, it's a little more than 4 kilos, and then it can hold 4 kilos of payload. So it's really lightweight. Why do we want a rocket which is really lightweight? Because we have cost propulsion. Of course, we want to have a motor which is the less powerful as possible to be also less expensive. We saw at Spaceport America, many teams, we were basically bragging about the size and the weight of the rockets. I think it's the opposite point. We want to make rockets as lightweight as possible, and while being able to carry a heavy and scientific payload. So I think that's the main point of the design. And yeah, the design was really iterative. So we started designing the structure, and then we went to do weight saving. We saw the possible alternatives for each component, keeping in mind the costs and everything. And yeah, in a really short time, we designed the rocket and we built it and we launched that. I can say that our design has also some pretty good technology in terms of additive manufacturing, because basically all components of our rocket are realized in 3D printing in advanced materials, which are provided by the university, luckily, with the exception of just 2 components, which is the nozzle disc and the tip, which are realized in aluminum. And this technology was also really helpful for the fins of our rocket, for which we were also awarded a prize for innovation at Spaceport America Cup.
How's the experimental rocketry community in Italy?
In Italy, the experimental rocketry community is growing really fast, and I'm very happy to see this, because of course we have some older teams such as Skyward and Trust, but in the last 2 years, I think a lot of new teams were born, ourselves, and then the team from Napoli, new teams also from Firenze and from Genova. Every team is working really well. They are growing really fast, and we understood that the only way to grow and to be considered by our industries is to work together. We can't always compete. Of course, we like to compete and we want to win when we go to Spaceport, to EuRoC, But to be really considered, we have to work together. So we are constantly in contact with the other teams. We work also with them. We had the first Italian rocketry engineering student summit in Turin at Politecnico, and I would like to thank Fabio and the executive of the team, and in particular Elena Di Lorenzo, who is our chief operating officer, for making this possible, and also Politecnico for giving us the spaces, because it was really an amazing event. Not only from the technical point of view, because of course our guests talked about really interesting aspects of aerospace engineering, but it was also a really fun and enjoyable moment. We know each other personally. Everyone liked it. For example, one member of my division, after the dinner and the party that we had after the event, wrote to me and saying that he was almost crying because that was the most incredible day of his life. Everyone really enjoyed it, and I hope that ERESS will become a tradition, and that we can repeat this event every year. Maybe not always in Turin, because I think it will be not only really cool, but it will be an important moment to know the state of Italian rocketry engineering community and how it is growing, and to improve this networking work that we are doing.
How do you test and measure the performance of your rockets?
First thing to do is component testing. We test components in our laboratories, and also ground testing, in particular for the avionics and for the recovery system. We do not do a propulsion test for our COTS motor because it is a COTS motor. However, of course, we will do static fires for our SRA liquid rocket engine when there is a need. And the best thing, of course, is to launch them, so to flight test them. Where do we launch them? Well, that's extremely complicated. In Italy, also with Andrea, we worked a lot to find a suitable launch site in Italy. Long story short, we did not find one which was, which complied to our requirements. So we launched our rocket in Germany, and for that we also have to thank the teams from Aachen and from Munich for their help. Also, the team from Danstar was there doing some ground testing. In Italy, it's kind of a gray zone. There isn't a really good regulation on this. And also handling black powder and explosives it's not a good thing to do in Italy without a permit. How many kilometers of free area do we need for the launch? I think Andrea can answer that. We did.
Yes, we worked a lot to determine this. Of course, it depends on the rocket. But with our actual rocket, with Cavour, we needed about an area with a radius of 1.5 kilometers to be safe. Of course, using the weather data that we collect on the site, we can really restrict this area. We can, I think, varying the heading and inclination of the ramp, we could launch and recover the rocket like 200 meters away. We really don't need this size of a space, but of course, for safety reason, we can't go to a launch site and ask them only for 200 meters. Safety is very important to us. We perform simulations in various scenarios. For example, we also considered the case of the double parachute failure. So the rocket launching and no parachute opening. The danger area was determined considering this.
But yeah, of course, luckily we didn't need the work of that simulation because everything went fine. But yeah, Italy is complicated. We work with the Italian Air Force, with the Italian Army, but the bureaucracy is, it really kills you. It's something really, really difficult for a group of students. And also you need some budget to work with them. The ideal launch place, well, of course, it will be something near the university, but it's basically impossible because in Italy there's always someone around. When we launched in Germany, we were basically in a field, so there were also roads really nearby. And it was a 10-hour, 11-hour drive, so it was really, really tiring. The ideal launch place, of course, Spaceport America, easy answer. That's the best launch place ever. Of course, it has its problems. Temperatures, the desert, it's not really great to work in. It's, basically it's good to work at around 5 a.m., 6 a.m. Then it gets so hot and it's really difficult to work on the rocket. But that's easy. The best launch place. I have not yet been to EuRoC in Portugal, so I do not know how is the launch site there. But I think that the one at Spaceport is, I don't think they can beat that, because there's a spaceport, there's a vertical launch area, there is so much safety. Everything is done really in a professional way. The launch ramps are perfect and they're already there, so you do not need to move yours. So yeah, but yeah, we're going to look for a better launch place, maybe closer to Italy. I think it will be really difficult, but we are always looking for launch sites.
EuRoC isn't a bad place to launch. They always have, I believe there are 5 launch rails. Almost all of the teams use their launch rails, except the hybrids and liquids. They sometimes use their own launch rails because to fuel them. Probably the worst thing about EuRoC is that you have to carry your rockets like 600 meters from the tent to the launch rail. But I guess that's safety, because you don't want to be a meter away from a rocket that's about to launch.
Yeah. At Spaceport, it was the vertical launch area is divided into two. There is the solid ramp site, which is 2 lines of ramps. I think in total it's around 16 ramps of solid propelled rockets. And then there is a hybrid and liquid launch site, so it's a really different launch site. It's really far away from the solids. And I think there are also more ramps there. And there's also another launch site for double stage rockets, which are quite rare, but there are some, and it's also another site. And so it's really big. And you go there with your truck, with your car. So you bring the rocket by car. I think it's maybe 1 kilometer of road, just in the desert from the tents. So yeah, of course, for safety. And then you unload, you load the rocket on the ramp, and then you go away with the car. So yeah, if in Portugal we will have to walk 600 meters, yeah, that's a lot. But yeah, of course, for safety, these things are really important.
Sometimes the Portuguese military gives their vehicles and they drive the teams and rockets around, but it's rare. Most of the teams didn't seem exhausted after the walk. I mean, usually there were like 5-6 people carrying the rocket, because those are the people who need to set up the launch. Yeah,
well, at Spaceport, luckily we had the cars, but there were some pretty heavy rockets. So I don't know if people. Well, there were some rockets which maybe 10-15 people needed to help lifting. And then they also had a car, Spaceport, which basically had, I don't know how to call it, but they had like a truck, and on this truck there were also many shelves. So it was a car where you can load your rocket. You could use your own car, but it was also the car from Spaceport, and it could carry like, I don't know, 10 rockets at once. Basically, that's many levels, many shelves. It was really cool. And then, 5 people were authorized to go load the rocket into the ramp.
So you weren't the person who loaded the rocket on the ramp?
Yeah, we were the person who loaded the rocket on the ramp, yes. But we did not, I think at EuRoC is the same. The ignition, the button which you want to press to launch the rocket, we didn't press it. The organizers had all the ignition keys and all the buttons to ignite rockets. We just inserted the our e-matches and our ignitors on the inside the propellants, inside the motor casing, and then we connected them and we went away basically.
Do you know of the OpenLaunchInitiative?
I'm not sure about it. Maybe we have heard of it, but not sure I know what it is.
Yeah, it was a project. Basically, the idea was that you have like 10-20 teams, and they all go to a spaceport that in which you can go up to like 100 kilometers. So the idea was, if you have 20 teams, each team would pay 1/20th of the price. However, we didn't do much progress.
Yeah, it's really difficult to find a suitable launch site.
I think this initiative is interesting, of course. If we lived in America, we had no problem doing that, of course. But we really struggled to find a launch site. To find one with no apogee limits, I think will be really hard in Europe.
Yeah, definitely. In America, they just take their cars, they go to Nevada or Arizona or New Mexico, and they set up a tent and they launch the rocket. Here in Europe, it's really difficult. Maybe in Spain, there is a desert.
Some islands in Portugal build a spaceport there, I actually don't know if they finished working on it, but basically there was this island, and you would launch the rocket from the island, and then, if you were lucky, the rocket would land on the island, but it would probably
Yeah.
land in the sea.
Yeah, definitely not good, And then you have to transport the rocket to this island, which will be definitely expensive.
I've heard that they are building a spaceport in Puglia, in Italy, but maybe in the future, if they finish this work, we could consider that.
There was also one in Norway.
Yeah, I think in Norway there's Andøya, maybe it's called.
Yes, if I remember correctly, we considered Norway for our launch.
In Andøya, which is an island in Norway, but the rocket they go into the water. So sometimes you get them back, and then it's really expensive to get your rocket back if it lands, in the water. So yeah, that's not good for us. And then the spaceport in Puglia, I don't know. Well, if they finish it and if they make us launch for free, that's definitely good. Otherwise, I wouldn't trust Italian bureaucracy.
How do you promote your team?
At the moment, we don't have a YouTube channel, but I think it will be a good thing to add in the future. Our official channels are LinkedIn and Instagram. We use mainly that. Most of our promotions work is done on the field by events and outreach events, in particular in schools. I believe this is a very important part of our public relations work. Of course, some of the students that we meet during this day, these outreach days and events, will probably join Politecnico, and maybe we hope that they remember about the fun day and the experience that they already had with us, and consider joining our team. And we want to inspire young students, and we hope that they can become passionate about rocketry as we are.
Could you tell me about your rocket?
Cavour, is a single-stage solid-propelled sounding rocket with COTS propulsion. It can mount a variety of COTS solid motor, ranging from the smallest one to the 98 millimeters ones. However, it has been designed for mainly 454 and 75 millimeters of diameter motors. The one that we launched at Spaceport had a 75 millimeter motor, a Cesaroni, so CTIL 1350, and it was in a configuration that allowed us to reach around 10,000 feet, so 348 meters. We had a really small margin of error for the apogee, which was really good because it meant that our simulations were really precise. Also, because the rocket, being our first rocket, we have no active control system or air brakes system, so we cannot really control the apogee besides doing the simulations and designing the rocket well for that apogee. The rocket is made out of composite materials such as fiberglass for the airframe, for the body tubes and the coupler, and advanced thermoplastic polymers, which we have 3D printed, such as, they have to be provided from the research lab of our university, which we collaborate with, which is called Mold 2. And most of these composite materials are reinforced with carbon fiber, continuous carbon fiber and short carbon fiber. This allowed us to have a really, really lightweight structure, which is our primary point of our rocket. The avionics system is mainly COTS. We have developed an ESRA flight computer, which we have inserted in our payload because we wanted to flight test it. So for our first flight in America, we used COTS component, and also the judges, the organizers said that it was a good choice because being the first rocket, you do not want to use some components that you have not flight tested. The recovery system is a double stage with a drogue pilot parachute, which is deployed at apogee, and the main parachute which is deployed later, a predetermined altitude, which is chosen before the flight, and the main parachute is deployed with a TD2 tether release device. The deployment of the parachute is done through the nose cone ejection. So there is only one ejection, which is done by a pyrotechnic charge, really small pyrotechnic charge. And it's the only ejection of the rocket. So the rocket stays then in one piece. And the airframe is composed of two body tubes of fiberglass, which are united by a fiberglass coupler. The fins, we have a delta clip fins, and we have 3D printed them, and they are optimized and reinforced with carbon fiber. And the fin set, the entirety of the fin set, it's really the big part of our structure, which was the one that gave us the first prize for innovation at Spaceport America, really the structure of the fins, because it is removable, and every fin is removable and exchangeable in case of damages. Of course, this was done keeping in mind with cost saving, because we do not want a fin set which, if one fin's is damaged, then you have to change the old fin set. With our fin set, or maybe the whole body tube, because there are rockets which have their fins permanently attached to the body tubes, to the airframe. We do not want them, so our fins are completely removable from the fin set and from the body tubes. So they are really easy to exchange in case of damages. The structure of the fin set, it's all 3D printed, and the fins are united by, of course, these components, which we have topologically optimized as every other component, with really good safety factor. So it's really good assembly.
What are your plans for EuRoC 2023?
The plan is to launch Cavour again and to achieve the best possible result, the best possible outcome. It will be our first presence at the European Rocketry Challenge, and it will be our second competition of the Spaceport America Cup. We know that the technical level at EuRoC is really high, because the European university are pretty good with their engineering and with their rockets. But yeah, we're pretty good too. So we hope to make the best possible result there. We will compete in the 3 kilometers category with solid COTS propulsion. A bunch of us will go. At Spaceport America, we were only 7 because, it's really expensive. At EuRoC, we will be around probably 20, probably even more than 20 people. The top competitors, well, we do not know. I mean, it's our first time, so we wouldn't know. Of course, our friends from Milan won last year, so they are, of course, pretty good. And but I think the level in Europe is in general pretty high. So it's really just an honor for us to go there after just 1 year of work and 1 year of existence of our team. Because it's I do not know any other team which in 1 year has launched the rocket and then went to Spaceport America and then to EuRoC. So that's already a big achievement, I can say. And we hope to make some also new, really good achievements at EuRoC.
What were some of the biggest challenges when you were designing your rocket?
We had some really bad problems in acquiring the components from external partners and from inside the university with all the bureaucracy that there is here in Italy. So definitely that's a problem that cost us many days of work. We were basically we stopped working for a while because we were waiting for those components, and that's something that we didn't really do not want to do. Building the rocket, designing the rocket, testing the rocket in 1 year, it's in itself a really big challenge. And another big challenge was the payload, because at the beginning we were relying on an external partner to have a payload, basically a reconfigured CubeSat, reconfigured in the form factor, because the actual rocket cannot fit CubeSats. So we developed an SRA payload in a really short time. A task force basically worked on that, and that was really the biggest challenge for Spaceport. And for Spaceport, the biggest challenge was, of course, also logistics behind that, because you want the rocket to go from Italy to the desert, to the middle of nothing, of nowhere. So that's not a big feat. I think for EuRoC, the biggest challenges remains logistics in the first place. Also, the payload is still a big challenge, and we are still working on that. And we'll see how it will go. At Spaceport, it went pretty well. We hope that also at EuRoC we'll be able to overcome these challenges and to make it good, really good results.
Yes, I think logistics for EuRoC will be critical because of how many people from our team will go there. Because of course we want as many people as possible to participate at competitions, because none of our members is paid. So we need them to get something for the work they do. So going to competitions is one form of reward. But managing a team of 21 people is not easy, and organizing the trip for every one of them, and the transportation when we get to Portugal, I think this will be the hardest part of the non-technical side of EuRoC.
What are your goals for the competition?
Well, the main goal that we already achieved is to represent for the first time Politecnico di Torino at the European Rocketry Challenge. And of course, we want to have a safe flight, and we want to have a good recovery. And we would like to get to the top category for the 3-kilometer category with solid gas propulsion. I can say that we are prepared for the competition because we have the experience from Spaceport America Cup, which was really, really a extreme experience, both in terms of daily work and of learning, because we really learned a lot. So we conducted test launches before the competition in Germany. We conducted a really successful launch in the US, in New Mexico, with really good recovery. And I can say we are more than prepared to launch again in Portugal.
How do you see rocketry evolving in the future?
We are getting always closer and closer to the industry. So I can see rocketry. We basically call it in the team, we call it rocket engineering. I can say it's a stronger term, and also maybe gave us a better idea of what we do. What we hope for is that our team is inside the evolution of rocket engineering in Italy, and of leading the development of the space sector in our country. I think that our team will have a pretty strong role in that, both with research and with the training of all the members. I'm sure that most members of PoliTo Rocket Team will then go on and work in the space industry in Italy and Europe, and they will have really a good training, and they will have a lot of meaningful and useful skills. In our rocket design, the innovative technologies, the main part is the additive manufacturing that we've done. That was not, from what they told us, the judges in the US spaceport. For instance, the design of the fins was completely innovative, and they have not seen anything like that before. And they said that this design, so with multi-layer fins with carbon fiber reinforcement, could also have an important impact on the industry of the launcher vehicles. So that's really a really good step for the team in having an impact in the industry and in the development of rocket engineering technology.
Yes, I think in the rocket industry, one of the aspects that will really improve in the future, not only for rockets, but mainly for spaceships propulsion, is the propulsion side. Because I believe chemical rockets are reaching the maximum efficiency that we can get out of them. And I think in the future, the new technologies such as the rotating detonation technology for rockets, and maybe I hope also the nuclear thermal propulsion will be key for this propulsion, and to allow space missions to reach goals that we can't imagine at the moment. And of course we can't work on this technology in the team because they are far too complicated, but I hope that some of us, after leaving the university, can work on these technologies that I believe are key for the future of our industry.
How much does your rocket cost?
Well, of course, we cannot state the details. I can say it costs really not much. Because we have done a lot of work in cost saving. In terms of of money, I can tell you it's under the 10,000, really under. I'm not going to state a specific price because each configuration has its cost, but it's really low. I think it's a lot lower compared to American rocket and other European rocket. I know that 0 to 10,000 is a big range, but of course I cannot state the exact costs. The name of the rocket is Cavour, which was one of the founding fathers of Italy, Camillo Benso Conte di Cavour, and it was from Turin. And he was one of the main actors in the industrialization of our country. So we want to, we wanted to name the rocket in his honor. And so Cavour is the first rocket of our founding fathers series. So each of the following rockets will have a meaningful name towards the founding fathers of our country and of the unity of our country. Our sponsors, they are starting to be numerous. They support us in many ways. Of course, the main partner is our university, Politecnico di Torino, which is the main financial partner. And we also have as our main partner the research lab MUL2 of Politecnico, which provided us with technical support, logistics support, thanks to the laboratory, and also with financial support for all the additive manufacturing. Many other sponsors, mainly for technical support and material support. So we have softwares, licenses, they give us components and other materials, and they give us, for instance, technical support in the way of checking our work, checking our reports, and so on. We do not outsource yet. However, we are working a lot in outreach, in STEM outreach. So I think that's the first way of outsourcing, for STEM outreach. And being in Turin, it's pretty easy to find what we are looking for in our area because it's full of industries and of potential partners.
How much do you build your rocket, and how much of your rockets do you outsource to sponsors?
We built the team, and in the beginning we had no facilities. We didn't have a laboratory, so it was not easy for us to manufacture components. Most of the rockets is manufactured by ourselves, with the exception of the body tubes, because we do not have an actual space to do them. The internal components are all done by us, and the aluminum components with CNC, they're provided by an external partner, but they're just 2 components. The propulsion is COTS, but we're working on an SRAD by liquid rocket engine. The avionics is both COTS, but we're also working on SRAD avionics, and the payload is entirely done by us. The recovery system is a mix of COTS and SRAD components. The parachutes at the moment are COTS as the shock cords, but next year we want to start to start cutting and start sewing parachutes and shock cords. It's not easy for us because our laboratory space, it's not really that large. So it's not easy to start manufacturing components, but that's definitely something that we want to do in the future, and I'm sure that we will be able to do it.
What software do you use to design the engine?
At the moment, we don't use any software to design the engine because we have a COTS engine. For the flight simulations, as I said earlier, we mainly use Openrocket and RocketPy at the moment. We are also developing our simulator using MATLAB because our university provides us with MATLAB licenses. So we are lucky and we can use MATLAB and Simulink. And the simulations in the future, I think will migrate to MATLAB and RocketPy because I believe RocketPy is more accurate than OpenRocket, and it is easier to work in Python. Mainly because most of our team members already know Python because we study it during the first year of Politecnico, and it is really easy to export and manipulate the data and the results of the simulations. I'm really glad that they just added the liquid motor class on RocketPy. I still hadn't had the opportunity to check it, but I will certainly do that in the next few days. And I'm happy because it will be really important for us when we have our bi-liquid rocket engine, and it will be needed also in the previous phase. So in the design of a rocket that will mount our bi-liquid rocket engine. And we also use, of course, in other divisions. I've talked about what we do in mission analysis division, but of course other divisions use other specific software. In the finite element analysis division, they use specific softwares.
Yeah, they use ANSA and Meta for pre-processing and post-processing. They are provided by our partner BetaCAI Systems, which are some really good softwares for finite analysis, for structural analysis, for static analysis, also for aerodynamics. You can work on that. We have softwares for topological optimization, such as Entopology or Inspire. And the CAD is mainly done on SolidWorks, which is pretty good software. And we're working on our own softwares for simulations, and I believe also in the bi-liquid rocket engine project, we're working mainly on softwares in Python, MATLAB, or C++.
What electronics do you use?
We mainly use our COTS components, such as Easy Mini altimeters and featherweight GPS. But we have built an SRAD flight computer, which is PCB, which is a flight computer that has the main functions such as the COTS ones. So it can detect apogee, can deploy the drogue parachute, and can deploy then the main parachute. And it has a GPS to track the rocket once it lands. This is done thanks to all the sensors and the software that will be written in C++. And also, of course, the data is acquired and to the ground thanks to our telemetry system. I can say in the future, there is a lot of work to be done in this because electronics is really complicated, and also telemetry and with antennas, it's still really, really complicated. But I'm sure that we can work on that in the next months. We had cameras on Cavour. Unfortunately, the extreme heat, basically it melted the cameras. They had 2 cameras, and one stopped working basically when we were mounting the rocket, and the other one, we had no feed. So we think it's because of the temperatures. In the future, of course, well, we have to provide a solution for this extreme heat in the launch pad because the cameras are not holding well. They were cameras integrated with a PCB, so they were not GoPros or external commercial cameras. And but cameras, I believe that's a really important point. It's not the primary function of the flight computer, but having a single system which provides apogee detection, GPS, telemetry, and then cameras is really good. And also live feed of the camera while the rocket is flying would be great, but that's still a difficult task.
What recovery system do you have?
2 parachutes, one drogue pilot parachute and a main parachute, some toroidal parachutes with a really high coefficient of drag, and we have ground tested all the system in our laboratories, and then we have flight tested it. So the main point is the nose cone is pops out of the rocket with a pyrotechnic charge, which is activated at apogee by the avionics system. The nose cone pulls a plate, which then pulls the drogue parachute. So the rocket starts slowly descending with the drogue parachute, and then at around 300, 400, 200 meters, it depends on what we choose, the main parachute is deployed. The main parachute is pulled by the drogue, and before being pulled, is kept in place by another shock cord, a shorter one, which is connected to a tether and release device. This device is activated by the next system, and the main parachute can deploy fully. So the separation is not mechanical, is thanks to pyrotechnic expansion with black powder. In the future, we want to, of course, avoid black powder, even though it's really reliable. It's extremely reliable, so that's a good point. But of course, we do not want to have explosive in the rocket. And we are thinking about mechanical separation, also CO2. And of course, parafoil is in the team's goals. I don't think for next year, maybe the next one, but that's definitely a good thing. And of course, we're using bright color for the parachutes. In our case, we had red and white for the drogue and yellow for the main. So it's really easy to spot after landing, and also you can see it during the flight if you're lucky.
Yeah, I think the main problem with black powder is just acquiring it. In Italy, it's really hard. So that's one of the reasons why we will probably change this mechanism in the future.
Can't you make your own black powder?
Well, at the moment, the team is focused, the not explosive part of the rocket. So we can make black powder, maybe. We have acquired gunpowder, but it's really not good. It's really of a bad quality, and it's all mixed with other chemicals. For our system, we have pure black powder, which, well, the university, they don't like having us going around with explosive and black powder. So no, we cannot make black powder at the university. But yeah, it's really difficult to acquire. Also, we're using, the purest black powder possible, which is completely different from gunpowder, basically, to have the shorter amount of black powder possible. So it's really 0.5, 0.8 grams of black powder, which is really a tiny amount, but it provides really good explosion for the ejection of the nose cone.
What is the payload of your rocket?
So at Spaceport America, the payload was called Ether, which was a data acquisition and transmission board system with cameras, but cameras were melted. And it was basically our flight computer that we tested. The computer had sensors for apogee detection and also telemetry. The form factor in the Cavour rocket is not a CubeSat one, because there is no space for the CubeSat. So it was basically a cylinder of 100 millimeter of diameter. And we also had a dummy mass at Spaceport because we needed to comply with the 4 kilogram requirement. Of course, a electronic board and cameras, it does not weigh 4 kilograms, so we had to put a dummy mass. We are in touch with other schools or research groups and also other rocket teams for payloads, and we are working with them. At EuRoC, we probably have the same payload, maybe in a modified form factor, possibly in a CANSAT. But of course, in the future, with a larger rocket, we'll be able to have CubeSats. The payload is, of course, is active, is powered, is energetic, it has batteries. It is not deployable, it stays inside the rocket.
Do you know Kerbal Space Program?
I do know, I do know Kerbal Space Program. Many years ago, when it came out, I started watching videos and playing it. I haven't played it in a while because I've been really busy. But yeah, it's really a really fun game and creative game.
I never played it actually, but I've watched some YouTube videos about this game, and I found it really interesting. And I know that now I think the second version of the game came out. I don't know if they already have a definitive version, an alpha version, or if it's still a beta version. Judging by the few videos that I've watched, there are still some things to be fixed. But I think they will do that in the future.
Yeah, but it looks pretty cool with all the colonies and stuff. It's great, really.
Yes, Kerbal 2 is still on early access. So if they don't update anything, then Kerbal 1 is better. But I hope that in future they'll add stuff to Kerbal 2.
Yeah, I'm sure they will.
Do you have any announcements you would like to make?
The main announcement is that, we're ready for EuRoC. We were ready for Spaceport, so we're coming. It's our first time at the European competition, and we want to get known between the European teams. As of now, in Italy, there is only one team from Milan in the European competitions and in general in the environment. But already with Spaceport, we had a really good placement in general ranking. We ranked around 20 in over 120 teams, and we had an amazing prize in innovation, and we ranked 13th in the 10,000 feet COTS category with over 100 teams which were participating. So that's really good result, and we want to have really good result too at the European competition. I'm sure that we have a really good launch.
Do you have any advice for young rocketeers?
An advice would be get involved with school, university, or other people. We are working with other students from secondary school, and they are amazing, and they have an impressive level of technology. I think Andrea can speak a bit about that.
Yes, there are a lot of secondary schools that are equipped with professional machining tools, and they are really very good at working. They will be ready to work if they want it. For example, the school that I attended in Fossano, that is called the Valauri, is really well known in our region because of the quality of its students and of the results that they can get. They have fantastic laboratories and tools. They are really ready to work on rockets if they want. Usually, rocket engineering is like the stereotype for a hard thing to do, but I really suggest everyone, any student, also young students who want to start building rockets, to just do that, because if they put the effort on it, they can absolutely do that. There is no limit.
And that's the same thing we did basically, at Politecnico. Well, yeah, there was a team, but there wasn't, a real team working on rockets for competitions. So, we founded it, we created it, and now we have almost 100 people working on it. And I say that also, if you're a student in Italy or in Europe and you want to collaborate, just talk to us, send us an email or contact us on social media. We're in contact with students from all around Italy and also from abroad. So we can definitely help you in the best way we can.
What are your favorite space movies or YouTubers?
I really liked First Man. So it's a movie, about Armstrong and in general the Apollo 11 crew. Maybe it's not really focused on engineering, but more about the human part of the Apollo 11 flight.
I think my favorite space movie, and probably my favorite movie in general, is Interstellar. How good it is on the level of detail they put on scientific aspects, physical aspects. I really also like the channel that is called Everyday Astronaut that I recently discovered, and I've watched a video from this channel about the evolution of Soviet rocket motors. It was really like illuminating. It was really interesting, both from the historical point of view and from the technical and engineering point of view.
Yeah, and of course in YouTube we have some good. Of course, everyone knows BPS Space. I think it has been really inspiring for many members of our team. There are also some good channels, YouTube channels of other student teams have really some good projects. And personally, I also like Stuff Made Here, which is a famous YouTube channel which does all kind of weird things with engineering.
Do you have any questions for me?
I think the main question would be how do you find the time to do all the things you do in rocketry, electronics, propulsion?
The trick is not being a university student.
Of course.
I basically don't do much else. I mean, sometimes during most of the year I go to school, but school takes up half of the day.
Yeah, I'm curious about where do you see yourself in 10 years?
I don't think about that much. It's a very hard question for me. And I guess I'll wait 10 years and see what the answer really is.
Yeah, what do you think about university? Just what university are you looking for?
I've been in 2 universities. No, I've been in 3 universities. I've been at Delft because the DARE rocketry team invited me. Delft is a nice city. I've also been to Milan for the Politecnico of Milano, and they also invited me there. And of course, I've been in the University of Catania since I live close to it.
Will you consider studying at Politecnico di Torino?
I mean, I will probably consider it, though. I mean, I don't know. There are many universities in Europe to choose from. So the probability that I will choose any specific universities isn't very high.
I think every university in Europe who has a rocket team is hoping you choose them. Because judging on what you already achieved, and I've seen some of your YouTube videos and your LinkedIn posts, so I've seen what you managed to build and to work on. I think you will be an extraordinary student and engineer in the future.
I mean, probably one thing that I have done is done lots of things on different topics. For example, I've made rockets, I've made electronics. I remember the time I tried to build a fusion reactor. I've done quite a lot of electronics recently, I'd say. I learned a lot quite fast. And also did some other random stuff, like building a wind turbine in an alternator.
I think this is the perfect mindset for an engineer, like being curious and finding challenges from different fields, and just getting started and building practical things and solving the problems.
I've found some challenges in the things I have done. For example, building the fusion reactor wasn't very easy.
I don't think it is really easy. Yeah, definitely.
No, probably the hardest part was the electronics, since I basically had done no electronics before that. And the electronics behind it wasn't very easy. I mean, it is very easy for me now, but it wasn't for me 6 months ago.
Do you think that nuclear fusion will be successfully achieved for the power production in the near future? Or do you think it will take a lot of years still to complete it?
I think it will be achieved, but to answer the question whether it will be in the near future, it depends on your definition of the near future.
Like in 20 years?
I guess that probably it will happen. Aren't that far away from having it be like outputting the same amount of energy as input energy. I remember there was a test in America some time ago where they managed to do nuclear fusion that outputted more energy than they put into it. Only problem was that the lasers were 1% efficient.
Yeah.
So they actually got like 60 times less energy than they put in as electricity. But I think that we might get there in like 20 years.
Yeah, let's hope so.
Yeah, definitely.
Let's hope. I mean, if you ask me, we should probably, at least for now, you should probably do more nuclear fission too. Like, nuclear reactors aren't bad. They're one of the safest ways of making energy. They don't emit much CO2 because, well, of course, you need CO2 to purify the uranium. But they definitely produce less CO2 than a coal power plant.
Yeah, definitely. And probably, yeah, we are really team nuclear in our team, but fortunately, Italy is not, now it's not the best place for nuclear. Unfortunately, I say.
And do you know
Yeah.
that there have been studies about using nuclear fission, like little nuclear fission bombs, to build rocket engines, to build spaceship engines?
Yes, like Project Orion, the
Yes.
post-nuclear propulsion.
Yes, I think I found that very, very interesting. It's like basically setting little nuclear bombs behind your ship and using the impulse from these bombs to push the spaceship. And I think they should really consider these technologies more, because sometimes they fear nuclear energy and nuclear technologies, but they are so good in my opinion.
Yes. Though this nuclear pulse propulsion sort of sounds like an idea a 5-year-old might have. Like, I need to go fast. I'll set off a nuke behind me.
Yes, but sometimes like the strangest ideas are the ones that become more effective, because it's like just thinking really outside the box. There are a lot of problems, of course, to be solved to use this technology, but I think we shouldn't exclude it just because it's nuclear bombs.
Probably one of the biggest problems would be that normally nuclear explosions don't last a very long amount of time, and they release lots of energy. So it wouldn't be a very smooth ride.
This is one of the problems to solve. But the fact that the explosions don't last a lot of time is also an advantage, because
I mean,
it's what makes it makes possible for the materials of the plates that are pushed by the explosion to survive the explosion.
No, but I mean, like, if a nuclear explosion would release the same amount of energy, but in like 10 times the time. Because, of course, if you would have it continuous with the same power output per second, then that would melt away a lot of stuff.
Yes, we'll see in the future if this technology is considered again. And
so I don't really understand what's pushing you forward. Is it like gases?
Yes, they put like hydrogen inside these little bombs that are called pulse units, and the mass of this gas is what propels the spaceship forward.
Guess it's not super efficient because hydrogen goes in all the ways.
No, it isn't, but the sheer amount of power inside a nuclear bomb is sufficient, even if exploited in an inefficient way.
It's like nuclear reactors. They have like a 40% efficiency, but it's still good enough.
Yeah, same concept.
Okay, since you have to go, I guess it's time to end.
Thank you very much for the opportunity to be in your channel and to talk to you. And I can say it's been a pleasure. I'm sorry that we had to delay the call so later in the year, but you were pretty busy. Of course, you're welcome to join us in Turin when you want. And, I think also Andrea agrees on that.
Yes, of course. We can host you whenever you want, and it was really a pleasure to meet you.
Well, thank you for being here. Bye.
Yeah, thank you. Bye, Etto.
Bye.
Bye-bye.
Goodbye.